Okay, part two of the 1.3 notes. First, we want to combine f of x and g of x by adding or subtracting to create a new function, and then we want to graph that new function. So starting over here with number 9, let's zoom in a little bit. Okay, so on number 9, we're giving two functions, f of x and g of x, and we want to find f of x plus g of x. Okay, let's not worry too much about this part right here. Let's just use this space to work. So we want to find f of x plus g of x. Okay, well, to find that, we're just going to use a little substitution. We have whatever f of x is plus whatever g of x is. All right, and then, well, what is f of x? Well, it's 2 minus x to the fourth, so then we want to plug that in here. And then plus, well, what is g of x? Well, g of x is x to the fourth plus x squared minus 5. Okay, and if we're adding these two polynomial expressions, we just want to combine like terms. So we got, let's do it in descending order, so from the biggest exponent to the smallest exponent. So I've got negative x to the fourth plus x to the fourth. Well, those are going to cancel each other out, so that's good. Those add up to 0. Next, we've got x squared, and then that's our only x squared term. So we get x squared. And then negative 5 plus 2, we get minus 3. Okay, so then we end up with, basically this is f of x plus g of x equals x squared minus 3. And then it doesn't matter if we call it this big long name, or we could just call it y equals x squared minus 3. Basically what we're graphing is x squared minus 3. Okay, so how do we graph x squared minus 3? Well, this is a quadratic, so we know it's going to be a parabola. And the minus 3 means it's shifted down 3. So instead of our vertex being at 0, 0, it's going to be at 0, negative 3. And then our a value is 1. We call that normal width. So we can go over 1 and up 1. Over 1, up 1 the other direction. And then those are called our lattice points. Now, if we want more points, we can always plug in points. Or we can use the pattern for a parabola. We go over 1, up 1 squared. Over 2, up 2 squared, which would be 4, which would put us here. We can go over 3, up 3 squared if we wanted to, but this is plenty of points to draw our parabola. It's going to look something about like that. All right, moving on to number 10. Okay, number 10. Now we want to find f of x minus g of x. So again, don't worry about this too much. We want to find f of x minus g of x. Okay? All right, so that means we're going to find something minus something else. Okay, well, what is my function f of x? Well, it's 1/2 times the absolute value of x minus 7. Minus our function g of x is just 5. Okay, and then when we combine like terms, we end up with 1/2 times the absolute value of x minus 7 minus 5, we get minus 12. Okay, and again, it doesn't matter if we say this is y equals that thing or f of x minus g of x equals that thing. What we want to graph is the function 1/2 times the absolute value of x minus 12. Okay, now for this one, it won't fit on the graph very well if we try to actually go down 12 spaces. So when you get a problem like this, just change your scale, meaning I'm going to say, okay, instead of every one box meaning 1 unit, every one box is going to be 2 units. So if we want to go down 12, just count by 2s. 2, 4, 6, 8, 10, 12 puts us right down here. Okay, and then this is going to be an absolute value function, which is going to be a V shape. The slope of my lines is 1, so I'm going to go up 1 over 2. Technically, up 1 over 2 would be going up 1/2 and over a full box. But, you know, we can go up 1 over 2. That's going to be the same thing. 1 over 2, up 1 over 2. And then once you have those 3 points, that's all you really need for your sketch is 3 points, your vertex, and 2 lattice points. And then we can draw our V, and then that's number 10. Okay. Last 2 problems here. Next one, number 11. Here we're working again with composite functions, where we're plugging a function into a function. Okay. So here we want to find f of g of x. So remember, this means we're finding f of something. And what's my function f? So ignore the x's because we're not plugging in x. We're going to plug in something different. My function f is 3/2 times something plus 3. Okay? And then what are we plugging into our function f? Well, g of x. Now we can write g of x if we want to, but what is g of x? Well, g of x is x minus 5, so then that's what we want to plug into our function. So I don't care if you call it f of g of x or y equals this stuff, but our function that we want to graph is 3/2 times x minus 5 plus 3. Now, we could simplify this if we want to, but we don't have to. What's this the equation of? Well, since it's x to the first and there's no absolute values in there, this is just a line that's shifted right 5 and up 3. So we can graph it by doing this. We can go right 5, up 3, and then there's a point on our graph. The slope is 3 over 2, so we can go up 3 over 2 to get a second point, and then that's enough to draw our line. Now, if you don't want to be way up in the corner of your graph, instead of going up 3 over 2, you can go down 3 and back 2. That's the same thing. So now we have plenty of points to draw our line. And it's going to look something about like that. Okay. You can also simplify this and get it into slope-intercept form, but then you're going to be stuck with some fractions. So this is probably a little bit easier. All right, and then the last one, number 12. Okay, so again, we're finding f of something. Don't worry about the g of x part. We're finding f of something. So what is my function f for number 12? Well, my function f for number 12 is 4 minus 3 times something squared. Okay, and then what are we plugging into our function f? Well, g of x. Well, what is g of x? Well, it's x minus 1. Okay, now this function is pretty much fine. Let's change a couple things though, just the way it looks. First of all, I don't like f of g of x. Let's just call that thing y. And then I want to put the 4 last, and if we write it like this, negative 3 times x minus 1 squared plus 4, well, now we had to write an extra plus sign, but now it's more in the form that I'm used to seeing it. Now we have a parabola. Okay, where is this parabola's vertex? Where is it shifted? Well, right 1 and up 4. So we're going to go right 1, up 4. And then I need a couple more points in order to graph. We're going to use the a value of negative 3 to get our lattice points. So we're going to go over 1, and then since it's negative 3, we're going to go down our a value, so over 1 and down 3. Over 1, down 3. And then those 3 points are enough. If we wanted more points, we can plug in other x values and solve for y, but these 3 points is enough, and we're going to get this downward parabola that's going to be pretty skinny. Okay. And that wraps up these notes.